Yeah, hello viewers. Welcome to Algebra class. So today I'll be teaching you indices and logarithms. So today I would like us to have a look at some major rules of indices, or you can call it the major laws of indices. So when you talk about the major laws of indices, here we're going to talk about the first law of indices, which I can call the addition law. When you have an index form like this. Now, looking at this, one thing you need to take note of is that both of them are having the same base, right? Which is base A, base A. So the rule says that if they're having the same base, then you can add the powers together. So the powers can be added together. Now, this is what you do. You can see they're having the same base, just make it a single base. And you do what? You add the powers together. So the powers is going to be m plus n. So this is the first rule for the addition. Okay. So the same rule can be applied to when you have division. Okay. So here it's going to be a to the power of m divided by a to the power of n. So when you have this is the same as what? A to the power of what? M minus n. So what changes in this is that for the first rule, multiplication changed to addition. And in the second rule, division changes to what? Uh, Subtraction. Now, in one of my previous videos I uploaded, I can see one of the students that made correction that, oh, sir, if you have a to the power of m plus a to the power of n, it was taught that it's going to be m plus n. No, this is invalid. This is invalid. Okay, when you have the bases separated by addition or subtraction, you can apply the same rule. Okay, the addition or subtraction can only work in the case of logarithm, but in the case of indices, no, it must be multiplication that turns to what? The addition sign. Now that's the second rule. Okay, now for the third rule is that if you have a to the power of 1 over m. Okay, a to the power of what? 1 over m. So this power can be in root form. So you can have m root a. So that is why in indices, if you have a to the power of half, is the same thing as the square root of a. Is the same thing as the what? As the square root of a. So that's when you can have that. Okay, now the fourth rule is that when you have a to the power of negative m, a to the power of negative m, the rule says that the negative sign at the power is going to turn to 1 over, okay, a to the power of what? M. So this is what you have. It's going to be a to the power of what? M. So the application of these rules is what I've been using for some of my previous videos on Olympiad questions and some other tough mathematical problems. But once you memorize or you know these rules, then you are good to go. Okay, now, so this is rule number 5, rule number 4. So for rule number 5, if you have a to the power of 0, that is, you're having 0 as a power, any value that has 0 as its power is going to be what? 1. It's going to be what? It's going to be 1. Okay, so these are the major ones in which you can lay your hands upon. We have some other rules, but for now, I believe, okay, let me just add one more to it because I know I've been using these two whenever I shoot my videos. Now, if you have a to the power of m and outside you have n, so you can easily multiply the powers together, okay? So you can have a to the power of what? M times n. So these are the major ones in which you can lay your hands upon. Okay. Now, after this, before I proceed with this, because I would like you to have a picture of the similarities and the differences between the indices and the logarithm. Okay. So I'm going to do the rules of the logarithm, then we can now move to the different examples we have. Now, for logarithm, we want to do something similar to this. Okay, if you have log A plus log B. Now, log A plus log B, or let me just use the same thing you are used to, which is log M plus log N. Now, if you look at this, you can see that in the case of indices, we have the two index separated by times. But in the case of logarithm, you have these separated by plus. The first thing I would like you to take note of is that whenever logarithm of a number is given to you, without the base being indicated, we assume that the base is what? Base 10. Okay? The general assumption is that we have it to be what? Base 10. Okay. Now, if you have it in this case, it shows that here you can have log m times n. Okay. So that means you have log m times n. Log m times n. This is what you have. Okay. Now, secondly, if you have log m minus log n, this is going to be log m divided by n. Now, look at the similarities and the differences. The similarity here is that, okay, now multiplication turns to addition. Here, addition turns to multiplication. Okay, in this scenario, you have your division turns to negative. Here, negative turns to division. Can you see the similarities here? Now, also for logarithm, if you have log m base m, the same thing. The base is equals to the number. Okay, it's going to give you 1. Okay, that is the rule which is not applicable to this. And also, if you have log m to the power of n, m to the power of n, this is the number, right? So here, your n can move to the back, okay, or to the front. So you bring your n here, and you have your what? Log m. So this is what you have. These are the major rules of what? Of logarithm, okay? These are the major rules of logarithm. And also, if you have log m, n to the power of a. Now, having the base is having its own power. If it is going to the back, then you can have 1 over a log n. So these are the major rules or the laws of indices and logarithm. Okay, so in my subsequent videos, probably I'm going to talk about the application of these rules. Okay, thank you very much for watching. See you next time.